Let's talk about how to calculate the measure of an inscribed angle. In our previous lesson, we learned about central angles, which are angles whose vertex is the center of a circle, like angle ACB. C is the center of this circle. It's also the vertex of the angle, so it's called a central angle. An inscribed angle has a vertex on the circle instead of at the center. So angle ADB would be an inscribed angle because its vertex is point D and D is on the circle. Another way to think about this is that central angles are formed from radii. AC is a radius and BC is a radius because they connect a point on the circle to the center of the circle. Whereas an inscribed angle is formed from chords. AD is a chord and BD is a chord because they connect 2 points on the circle, but they don't pass through the center as they do so. So that makes them both chords. We learned in the previous video that the measure of a central angle is equal to the measure of the arc that it intercepts. But inscribed angles are a little bit different. The measure of an inscribed angle is equal to half the measure of the arc that it intercepts, which also means that it's equal to half the measure of the central angle. So for example, if I knew that the measure of angle ACB was 64 degrees, then the measure of arc AB would also have to be 64 degrees. That's what we learned in the previous lesson. But we're learning today that that means that the measure of angle ADB, the inscribed angle, is half of 64. It has to be 32 degrees. So let's try an example. What's the measure of angle PQR? Well, angle PQR is an inscribed angle because its vertex is a point on the circle. And the measure of an inscribed angle is always equal to half of the arc that it intercepts. So the measure of angle PQR must be 48 degrees because that's half of 96. Let's try another one. The measure of angle MJK. Well, it's an inscribed angle because its vertex is on the circle. And we're given the measure of the central angle that intercepts the same arc. The measure of angle MLK is 128 degrees. So the measure of angle MJK must be half of that. It must be 64 degrees. Let's try going the other direction. This time I'm giving you the measure of the inscribed angle. The measure of angle XYZ is 74 degrees, and XYZ is inscribed because its vertex is a point on the circle. So then what's the measure of the central angle who intercepts the same arc? Well, if an inscribed angle is equal to half of the central angle, then I would need to double the inscribed angle to get to the measure of the central angle. So the measure of angle XWZ must be 148 degrees because that's 74 times 2. For our next example, we need to figure out the measure of arc AC, given that the measure of angle ABC is 52. Well, ABC is an inscribed angle because it has a vertex that is on the circle. AC is the arc that it intercepts, and we know that an inscribed angle is equal to half of the arc. Well, I don't know the arc, I know the angle. So to get from the angle to the arc, you double it. So the measure of arc AC would have to be 104 degrees. So if AC is 104, half of that is 52. Yep, that all checks out. Don't be afraid of getting really big answers. I have students every year that think they're doing something wrong when they get an answer like 212 degrees. But we're talking about circles now, and circles have 360 degrees total, so it's totally normal to get big answers. I got 212 degrees for this because EFG is an inscribed angle. I can tell it's inscribed because its vertex is on the circle. And I'm asked to calculate the measure of arc EHG, which is the arc that it intercepts. So to get from the inscribed angle to the arc, you double it. So double of 106 is 212 degrees. So I know we've done a lot of doubling and cutting in half today, but don't forget about what we learned in the previous lesson, which is that central angles are equal to the arc that they intercept. So you don't always have to double something or cut something in half, sometimes they're just equal to each other. Angle XZY is a central angle because its vertex is the center of the circle, so if I need to figure out the measure of arc XY, well, it's just 118 degrees because central angles equal their arcs. And if I need to calculate the measure of XWY, this big arc, well, I can just subtract 118 from 360 and find out that that's 242. So there was no doubling or cutting in half for these because there was no inscribed angles. Instead, we had a central angle. So just remember that central angles are equal to their arcs, whereas inscribed angles are equal to half of the arc. This is kind of an interesting problem. We don't have an angle measurement given, instead we're given this little square, but we all know what that little square means. It's a 90-degree angle. So if I need to calculate the measure of arc RTG, well, this angle, this right angle, is an inscribed angle, and RTG is the arc that it intercepts, so I just double 90 and figure out that the measure of arc RTG is 180, which actually means that RTG would be a semicircle. It also means that segment RG would be a diameter. What's the measure of angle PQS? Well, PQS is an inscribed angle because its vertex is on the circle, and I know that inscribed angles are equal to half of the arc that it intercepts. PS is the arc that PQS intercepts, so PQS must be 24. Okay, well, what's the measure of angle PRS? Well, PRS is also an inscribed angle because its vertex is on the circle, and angle PRS also intercepts the same arc, this 48-degree arc. So that means that angle PRS is also half of 48, which means it's also 24. So what we're learning here is that if two different inscribed angles intercept the same arc, then those inscribed angles are equal to each other. We call those a common arc. So the red inscribed angle and the blue inscribed angle both intercept the same arc, this purple arc CD. Therefore, we can conclude that the red angle is equal to the blue angle. Let's try an example. We're supposed to figure out x, which is the measure of angle PRQ, and that's an inscribed angle because its vertex is on the circle. We're given that this other inscribed angle, PSQ, is 43 degrees. And the interesting thing is that these two inscribed angles intercept the same arc. So that means that these inscribed angles are equal to each other. Angle PRQ must be 43 degrees as well. So what do you think about each of these angles? The green angle, the red angle, and the purple angle all intercept the same arc. That arc is 64 degrees, so each of these inscribed angles would have to be 32 degrees. All three angles are equal to each other because they're all inscribed angles that intercepted a common arc. And that's all you need to know about calculating inscribed angle measurements. In the next part of this lesson, we're going to discuss how to calculate the angle measurements in inscribed polygons.